Hello guys, this is the bonus number one for the topic of completing the perfect square trinomial. So let's go straight ahead. What is the problem that we face? The problem is this. Given the expression x squared plus kx, can we find a number r such that x squared plus kx plus r is a perfect square trinomial? That is the problem. Can we find such number r such that when we add it to this expression, which is a binomial, the whole thing, this becomes a perfect square trinomial? That is the problem at hand. Okay, how do we solve it? We solve it in the following way. Mathematicians often do the following. When they face a new problem, they they basically what they do is they try it. Okay, they try to solve it. It's like an engineer, you know, if an engineer is given the task of building, let's say a, I don't know, 500 meters kilometer, I'm sorry, 500 meters building, and such a thing has never been done before, how do you know if that's possible or not? Well, basically the approach is give it a try, give it a shot and see if it works. And mathematicians often do the same thing, okay? It's the same approach. So what I'm gonna do is this. I'm gonna try to say that I'm gonna think out loud, okay? I'm gonna try to add a number to this expression, and remember we know x. I'm sorry, we know k. We know this value, but since this is a general demonstration, I cannot put any particular value for k. I cannot put 2 or 3 or whatever. I need to be general. In any mathematical demonstration, you can never use specific numbers. Okay, what is the constant in here? The constant of the linear term is k. Do we know it? Yes, yes we do. So can I add a number r in here? Can I add a number r such that all of this is a perfect square trinomial? That is my question. Okay, let me suppose that such thing is possible. So I'm gonna add that number plus r. Fine. Now let's keep going. If this is a perfect square trinomial, by the very definition of a PST, this has to be equal to a linear binomial, which I'm going to write in this way, x plus another constant, another number, which we don't know yet, to the square, right? Why? Because this is supposed to be, by hypothesis, a perfect square trinomial. So it has to be equal to some binomial, some linear binomial, to the square. That's the first thing I'm going to do. Okay. And then I'm gonna continue with my reasoning. Okay, I'm gonna start right here, and I'm gonna let the deduction process go on and see where that takes me eventually. And hopefully we can find an answer. So why don't we raise to the square this binomial? Let's do it. X squared plus kx plus r equals x squared plus 2xs plus s squared, right? I just raised to the square this binomial. Very simple stuff. Okay, next, since I have x squared from both sides, I'm gonna subtract it from both sides. And what I get is this, kx plus r equals 2xs, which I'm gonna write in this way, 2sx. Instead of 2xs, 2sx. It's the same, right? Plus s squared. Perfect. Now, a little fact about mathematics here. I want you to pay attention to these two expressions. This one, which is a linear binomial, right? In x, your variable is x, and this is another linear binomial in which your variable is x. What are my constants? K, which we know. We know k. That is the only constant we know. Do we know r? Not yet. That is the value that we're trying to find. Do we know s? No, we don't. But it's just a constant, okay? It's not a variable. The only variable in these two expressions is x. So basically, we have two binomials which are on the variable x, which are the same. Why? Because of this equal sign, right? This is the same as this. Okay, and when you have that in mathematics, when you have a binomial equal to another binomial on the same variable, then the terms, the constant, the coefficients of the terms have to be also the same. What does that mean? It means this, that this k, being the coefficient of the linear term, has to be the same as this coefficient of this linear term. Kx has to be the same as 2sx, and therefore k is equal to 2s. And the constant term in this coefficient, in this binomial, has to be equal to the constant term on the other binomial. Why? Because the binomials are the same, like we said before. Okay, so I know I can make this deduction. K has to be equal to 2s, and the constant term r has to be equal to the constant term s squared. Okay, perfect. Now, remember, what are we looking for? We're looking for r. And if you know here, if you notice, it says r equals s squared. Do we know s? No, not yet. We don't know that number, right? If we'd known this number, we would be finished. But we don't. But if you notice in this other equation, we can get s. Why? Because we know k. Remember, k is the only constant that we know. And since I know k, I can know s. How? I just isolate s from this equation. I'm gonna divide over 2 in both sides, and it gives me that k over 2 is equal to s. So do I know s now? Yes. It's gonna be equal to k over 2. You see, we have found the value of s. And I just need to plug it in here now, right there. R will be equal to s squared, but s is equal to k over 2. So it's going to be k over 2 raised to the square. And if you realize, we have found our number r. Why? Because r is equal to k over 2 to the square. Do we know k? Yes, that's the only concept that we knew from before, from the beginning of the problem, and therefore we have found r, and we are done, guys. And if you notice, in fact, it's the same number that I told you in the previous video that you have to use in order to complete the perfect square trinomial. It is the square of the half of k. And what is k? It's the number, it's the coefficient of the x. You see? Look at this. Look at this. Remember, in order to complete the perfect square trinomial, I always told you, look, pick this number, divide it over 2, and square it. And we added this number, right? Which is in fact the same number that we just found. Can you see? And that is this is the demonstration of how we get this number r, the constant term that we have to add to both sides, in order for this thing to be able to convert this thing into a perfect square trinomial. So I hope you have gotten it. Try to do it on your own. You know, it's always 2 or 3 or 4 times. Understand what you're doing, and trust me, if you do these type of things in mathematics, this is real mathematics. You know, this is the mathematics that I want to teach you. You will get very skilled. So that's it, guys. Thank you.